Alright, so yesterday in the last class we talked about section 4.1. So we'll move into section 4.3 first, and then we'll go back to 4.2 because it's a brief section. So in this section we'll talk about the trigonometric functions based on the right triangle trigonometry. Okay. So I think we all are familiar with the right triangle, right? So any angle which is 90 degree is right angle. So any triangle where we have a right angle is called right triangle. And all of the trigonometric functions are based on the right triangle. So as you can see from the top left triangle, there are three sides in triangle just like the regular triangle. The only difference is here there is a angle C, capital C, which is 90 degree. That's why this is right triangle. And there are some specific properties of the triangle, right triangle. First of all, it's not properties, probably the way we write the triangle. We always write the triangle in case of trigonometric discussions. We write the angles by capital letters. So anytime you see any capital letter like capital A, capital B, capital C, those are angles. Okay. So here you have three angles, A, B, and C. At the same time, you have three small letters, which are small a, small b, and small c. Those are three sides. And if you look at carefully, that the side and angles are basically the opposite. For an example, the opposite side of angle C is a small c. And the opposite side of angle B is small b, the red line. And the opposite side of small a is a small a. Now this is a convention we always follow when we talk about the trigonometric functions. So be careful about that. So anytime you see or you want to write the triangle, be careful, and you always want to write the triangle in this way. Okay. In general, we always treat the right angle by C, by capital C. Opposite side is called hypotenuse. Do you see the hypotenuse here, the blue line? This is the largest side
in the triangle, right triangle. That is going to be the largest side in the right triangle. And there are other two sides as well. So out of the other two sides, meaning either A or B, we treat one as a theta. Now remember, it can be either A or B. At this point, that is A in our picture. We assume that A is the theta. Okay, so we always take one angle as a theta from either from A or B. It will be either A or B. Now at this point, that is your A. Now whenever you see that theta, you will also notice that the reverse side of that theta, okay, look at the reverse side. So here the green side, that is the reverse side, that will be always called opposite side. Okay, remember, it depends on how you are writing your theta. For an example, in this case, since you are treating or you are denoting the A by theta, so this is going to be the green line is going to be your opposite side. Okay, and the blue and the red line is going to be your adjacent side. Now let's say if you are drawing the same triangle, let's say we are drawing the same right angle. Let's say I have drawn here another right triangle. So this is the capital C, small c, capital A, small a, capital B, small b. Now we know for sure this is 90 degree. We also know this is hypotenuse. There is no change. But the theta, either we can assume this is at the theta, or we can assume this is at the theta. That's our choice. Now, what happens if we choose this one as a theta?
In that case, this b, small b, is going to be your opposite side. And this side is going to be your adjacent side. So be careful about that. Okay. Sometimes you might see the other one. So it depends which one you assume as a theta. So anytime you assume A as a theta, so in the picture you see the green line is going to be the opposite side, and the blue line is going to be the red line is going to be the adjacent side. But in the picture in the board, you see we just swap the theta. We flip the theta so that because theta can be A and B, A or B. So when you assume this is at a theta, this is going to be your opposite side. Okay. So in trigonometric discussion, since we every function, trigonometric functions, take theta as an input. Okay, so it's really important to understand which one is the theta. Now, interestingly, all the functions are true. It doesn't matter which one you take as a theta. Okay. Now let's come back to those functions. Now at the bottom, you are looking at 6 trigonometric functions. Especially, don't look at the 3 at the right side. Look at the 3 at the left side, because the 3 functions you have at the right is basically pretty much similar. It's just the reciprocal of the 3 you have in the left. So let's see whether we understand this. Now, all these are trigonometric functions. Okay. Now, what are these functions? Now, first, let's see whether we can. I think some of you have already seen it in some other discussion or some other class. The first one is called sine theta. Okay. So this is the sine theta. This is cos theta. This is tan theta. Sine, cos, tan. Okay. So these are the shorter names. Especially the names are sine, cosine, and tangent. But in short, we call them sine, cos, and tan. If you even look at your calculator, I think in every single scientific calculator, even in your TI 83, 84 plus calculators, you will always see all those functions are built in. So you already have those. Okay. Now, what are these functions? What they do or what they give? That's an interesting question. Look at their formula. The sine theta is cos theta or tangent. They basically give you a ratio. Okay, and basically they take the ratio and they will give you the answer. So look at the sine theta is the length of the opposite side divided by length. It's always like that. Length of the opposite side divided by length of the hypotenuse.
Length of opposite divided by length of hypotenuse. I'm sorry. Length of adjacent. So, if you look at the other 3, this is called cosec. This is the second or sec. In short, we call cosec, sec, cot. Now, these are just the reciprocal of these 3. So they are not new. Look at this. What do you get? It's basically A by C, right? Because small a is the opposite side there, right? Small a. Do you see small a here as the opposite side? And the hypotenuse is small c. So it's A over C, B over C, and A over B, and they are just reciprocal. Okay? So A over C is here C by A, C by B, and B by C. So they are nothing new. So they are just like the same 3 ratios. So if you understand the first 3, we'll understand almost all of those. Now, interestingly, as you see here, these functions, as we are calling them functions, in general, by function we understand something like it will take an input and it will give you an output. Right? Remember, we discussed about functions for the whole chapter 1, and every time what you noticed is, for an example, you are given a function f of x, and let's say something is already, there is an equation for that function, and
when you assume x equals to 5, you get some value, right? Let's say that's 10 after you plug in x into the function. So what basically is the purpose of the function is, you have an input, function takes that as an input, and function will give you an output. Similarly here, all these trigonometric functions take the theta as an input. Now, since the theta is an angle, what can be the input? It can be, let's say theta is 30 degree. So you are, in that case, you are finding sine theta, sine 30 degree. Theta can be 60 degree. Let's say you are finding cos 60. Or you are finding tangent or tan 30 or tan 60 or tan 45. These are different angles, and you are finding the tangent for them. Now, the interesting thing is, these functions are kind of constant functions, because let's say you have sine 30 for an example. Now, sine 30 equals to half or 0.5. Okay, what does it mean? It means that doesn't matter however you write your or you draw your right triangle. Let's say you assume, let's say I assume this as a theta. Okay, now how big or how small the triangle, the whole triangle is, as long as this is 30 degree, the ratio of opposite and hypotenuse will be always half. That's what exactly is telling you, because look at the sine theta. It's nothing but the ratio of opposite and hypotenuse. That means length of opposite divided by length of hypotenuse. So, for an example, let's see whether I probably have an example here. So, look at some of this example. We're just trying to show you some picture. Look at this here. Let's say in this triangle, even in this triangle, these are 4 different triangles. I'm saying, remember, in these chapters, anytime I mention triangle, you always assume I'm talking about the right triangle. Sometimes I forget to mention right, but that's always right triangle, because all these trigonometric functions are applied only to right triangle. Now, look at the 4 triangles. Their shapes are different, right? Quite different. But what are common between them, among them? Number 1, all of these are right triangle. Number 2, all of the thetas are same. For an example, let's say theta is 60 degree in the first triangle. Theta is 60 degree here as well. Theta is 60 degree here as well. And theta is 60 degree here as well. It's possible, right? Because, I think whether you heard it or some class, I thought you probably should have known it from 850 that any triangle, doesn't matter how you draw it, doesn't matter what triangle it is. Now, similarly, this is also true for right triangle. But let's say you can draw
this 4 triangle, especially right triangle, and all the right triangle has the theta, right? And all the theta is 60 degree in this case. It's not mentioned here, but that's 60 degree. Now, and based on that, we figured out that B is 2 and A is 3. These are the length. Let's say A is inchy, so it's inchy or whatever unit you have. So look at this. At the end, all this triangle has the same answer for the tan theta. Do you see it carefully? First triangle is 3/2. Second triangle, it was 6/2, but when you simplify it, it becomes 3/2. The next one is basically 1.5/2, which is, again, it's 3/2. 3/2 is 1.5, right? And also, the last one is again 3/2. So this is what exactly I want you to look at, that why these trigonometric functions are constant. Because for a same theta,
Doesn't matter how big or small the size of the triangle, right triangle, you will still have the same value for that tangent, or for that sine, or for that cosine, or for that cosec, or for that sec or cot. Doesn't matter, okay? So that's why all these functions are kind of constant functions. And these functions are extremely useful. We'll show you a lot of examples and also some application examples. Then you will realize the importance of all these functions. At this point, I'd like to go back to the previous slide just to make sure that we know that we can remember those. These are some memorizing aid so that we can remember. I know that some of you are extremely new to these concepts. So we want to make sure that we remember the ratios, at least for the sine, cos, and tan, because as long as you know the sine, cos, and tan, you'll automatically know the cosec, sec, and tan, and cot, which are in the second column. So there are several options. One option is, some people use this line, that some old hog came around here and took our apples. If you just remember this line, so what they do is just try to remember this, S-O-C, here S-O-H, from here they remember S is for sine, and O and H is opposite by hypotenuse. And then cosine, adjacent by hypotenuse, and then tangent, opposite by adjacent. You can remember only this line. It's you know, people found a lot of different things, and even if you Google, you probably will find some more exciting one if you want to. Now, and also, if you just use your calculator, you will always get, it's not for only for 30 degree, for any degree, you will get the constant for all the trigonometric functions. Let's say, what is sine 35, what is sine 45, what is sine 69. All these are constant. Okay, there is a huge chart for all of those. Even when the degrees are not the whole number, let's say the angle is like 65.5 degrees, still you will get a constant number. But these are constant functions. As you have seen, that doesn't matter how big or small the triangle it is, as long as the theta is same, you will still have the same answer. So let's see whether we understand some basic question here. Find the value of each 6 trigonometric functions of theta if b equals to 4 and c equals to 2 square root 5. Now, one of the important information here for you is, you are given b and c, but you are not given a. You see that? Small a is not given. And you don't know even theta. Theta is just mentioned theta. Okay, my first question is, how do you find a small a? Okay, anybody remember Pythagorean theorem? I think that was taught in BSPM. Okay, it's a very simple formula. So, in Pythagorean theorem, that's an extremely simple theorem that is only applied, is only true. Remember, it's not true for
every triangle, it's true for every right triangle. Now, just looking at this, you know that C will be always the hypotenuse. A and B, either one will be the adjacent, other one will be opposite based on which one is the theta. But Pythagorean theorem tells you that C square is always equal to A square plus B square. Okay.
So from this formula, this is an extremely important trigonometric formula. From here, you can always find the length of any side when other two sides are known. If you know two sides, you will be automatically know the third one using the formula. For an example here, let's say you are given C and B. but you don't know A. So let's plug the C and B here and see whether we can find A. Now, what is C? 2 square root 5 whole square, and A square, and what is B, which is 4. Now this is, what is 2 square root 5? 2 square is 4, right? And the square root of 5 square is 5. So it's 4 times 5, 20, equal to A square plus 16. When you just do all the isolation, you will get A square equals to 20 minus 16 equals to 4. So A is 2. Basically the A is plus minus 2, because since you are doing the square root, but we ignore the negative sign because we are talking about the length, and length, technically the length is not negative. So you know now that A is 2. And look at the theta carefully, because as I said, remember, whenever you have a theta, you will know based on that which one is your adjacent side. Now from this picture here, what is your adjacent side and what is your opposite side? Small a is the opposite side, because your A is theta, so this is your opposite side. It's always based on the theta. Since this was the exceptional one, other one. Since this is the theta, this was the opposite side, and this is the adjacent side, based on the theta. So if this is the theta, so this is going to be the opposite side. This is going to be the adjacent side. Now, do you want me to go back to those, or you just want to remind yourself this line so that you will know how maybe you can write down the line, and then just from the line you will know what are the sine, cosine and tangent. And if you know sine, cosine and tangent, you will also know that cosec or sec and cot, because they are just reciprocal of, cosec is reciprocal of sine, sec is reciprocal of cos, and cot is reciprocal of tan. Everybody got the line? So let's go back to that question and see whether we can find out all the trigonometric functions. All 6. Now, based on these ratios, let's plug these ratios. A is 2 square root 5, which is 1 over square root 5. B is, so cos theta is B by C, which is 4 by 2. Oh. So look at all the ratios and see it matches the answers. If you knew the theta, then you can even use the calculator to get the answer. Since we don't know the theta, we cannot plug into a calculator and get the answer. Alright, so here we have some spatial angles which are extremely frequently used in trigonometry. We know that when you have calculator you can find the angle of almost everything, but we also want to make sure that we see some of the very frequent angles: 30 degree, 45 degree, 60 degree, 90 degree. For those, some of the ratios are given here. Okay. Now I can give you one more way to, instead of remembering all of these value, the common ones, you can use another aid which is very simple to remember. As you know that as long as you know sine and cos, you will be knowing almost everything, because the tangent is nothing but sine over cos. If you know sine, and if you know tan for one angle, sine and cos for some angle, sine by cos, you will again end up with tan. Okay, so important is how to find sine and cos for the common angles. So what I do, just for me, I'm not sure whether you have it in the book. I have not seen it. So what I do is I just write 1, 2, 3, 4. Very simple. And then I divide everything by 4. And then what I get? And I do the square root of everything. When I do this, what you are getting from here? This is going to be half, right? We are doing the square root. So square root of 1 is 1, but square root of 4 is 2. Just take the positive value. What do you get from here? 1 over square root of 2, right? Because this 2 and 4, if you just cancel the common factor, it will be half. So square root of half is 1 over square root 2. And then this becomes square root 3 by 2. And this one is just 1, right? Now once we know it, I just write the degree here. This is 30 degree, 45, 60, 90. And all these are the values for sine. Okay. So this is sine 30, this is sine 45, sine 60, sine 90. And interesting is, for the cos, for the cosine, this is 30, this is 45, this is 60, yeah, and this is I missed one. Let me just add one more column, then it should be fine. So I basically start from 0. 0, 1, 2, 3, 4. So I divided it by 4, and doing the square root you will get 0. Okay. So this angle is 0 degree, sine 0. And the cosine cosine has the same values but in reverse order. So this is the cosine 0 degree, 30 degree, 45, 90, 60, and 90. And interesting is, one you know sine and cosine, you know almost everything, because you will know tangent, and the other three are just reciprocal. Cosec, sec, and tangent. Cot. So again, you don't have to memorize everything, but it's just the memory aid. If you want to just make it extremely handy, even without the calculator, let's say just looking at those angles, because you see those angles extremely frequently in almost in every trigonometric discussions. Okay. Now, you can answer this question even right away without looking at the calculator. Cosec 30. Okay. Remember the sine 30, right? This is the sine 30, which is half. And cosec is just the reciprocal of sine, so it's going to be 2. What is the sec 30? Sec is reciprocal of cos. So this is your cos 30. So sec 30 is going to be reciprocal of this. It's 2 over square root 3. The last one, cot 30, is reciprocal of tangent. So tangent is nothing but the sine and cosine. So let me show you that. What do you do? So let's say you want to find tangent first. Then 30, which is nothing but sine 30 over cos 30. So look at our chart there. Sine 30 is half, and cos 30 is, so if you do the math, it will be it's going to be 1 over square root of 3, right? Now cot 30 will be the reciprocal of tangent, so it's going to be square root 3. Make sure that you understand how we are getting those answers. Check your calculator whether you get the same answer.
Just write 30, press sign. You will get 0.5. Calculator will not give you the fraction. Calculator will give you decimal fraction. Right? It will give you the decimal fraction. But just to make sure that you can also find it in the calculator, you should check that you can get these values from the calculator. Any question? All right. Interesting is some of the trigonometric functions can be related, okay, by the co-function of the other trigonometric function. For an example, look at these examples here. Sine theta is nothing equal but is equal to cos 90 minus theta. See, you exactly see this here. Okay, for an example, if you look at this carefully, look at this. Sine 30 is equal to basically cos 60, right? What it means? Sine 30 is nothing but cos 60. So let's write this first. Sine 30 is cos 60, right? How can you write this? Cos 90 minus 30, right? Look at this. If this is the theta, this is going to be 90 minus theta. So they have extremely interesting relation. Sine and cosine, tangent and cot, sec and cosec, cos and sine, again the reverse order, cot and tan,
cosecant sec. You have the pretty much the similar relation. And these are also called cofunction identities. The reason they are so similar and there are so many ways of different relations between these functions, because all of those are coming for one single triangle, and they have several properties between their angles and constant ratios of the sides based on the angles. So, can we find a cofunction of the same value given with the expression? What is the cos 20 then? Look at the cofunction. Cos is related to the sine, right? Do you see that here? Look at this. Cos is related to sine. So how can you write cos 20? Cos 20 should be sine 90 minus 20, which will be sine 70. So cos 20 and sine 70 will have the same value, same constant, because of the cofunction relation. How about the cot 40? Look at the cot. Cot has the relation with tangent, tan, right? So cot 40 will be equal to tan 50, right? Because all you will be doing is subtracting from 90. So cot theta equals to tan 90 minus theta. So it's going to be tan 50. Similarly, the cos 20 degree equals to sine 90 minus 20. It's going to be sine 70 degree. Any question? So let's look at a couple of applications, and you'll be really surprised to know how there are plenty of applications, but we will not be able to cover all of those, but we'll show. An angle is formed by a horizontal line and the line of sight to an object. Okay. Now
here, look at this. We have someone here in the level 3. So he has some, this is his horizontal line, okay, and this is his line of sight, and this is his line of sight as well. So it's basically, we identified these two lines as line of sight above the observer because he is here, and this is above his location, and this is under his location. So this is below his location, is line of sight above, below the observer. But in both places there is an angle of elevation created because of his position and those other two objects' position. Okay. And also, this is called angle of depression because that's the downward one, and this is called angle of elevation. Now, sometimes people use this information to calculate this kind of heights. Let's say you know this height, okay, then you also know this angle. From these two relations you'll be able to find what is the length of this side, because any trigonometric function makes a relation between two sides, not all the three sides. Remember, opposite by hypotenuse or opposite by length or something like that. So what does it mean? It means that if you know there are three information, one is angle and there are two sides.
Now, out of those three, if you know any two, you'll be able to find the other one. So for an example, if you know this angle of elevation or this vertical height, you will always know, you'll be always able to tell this length. You'll be also know what will be the line of sight from the observer. Okay. So this is another interesting example here. The irregular blue shape is a pond, okay, and the distance across the pond A, which is from here to here, there is a distance which is A, which is unknown. You don't know it. The distance across the pond is unknown. To find the distance A, someone took the measurements shown in the figure. What is the distance across the pond? Now, look at this, what you have right now. You know this angle. You also know this length. Now, the question is, can you find the A given these two information? Of course you can, because you know one angle, you know one length. You will always know the other one. Now, can anyone here tell me what might be the best trigonometric functions? We have 6, right? Cos, sine, tan, cosec, sec, cot. What may be the best choice? Tangent will be the best choice, because tangent relates the length and, I'm saying, the opposite and adjacent, right? Because you know the adjacent. This is adjacent, right? Why this is adjacent? Because this is your theta right now. If this is your theta, this is going to be your opposite, and this is going to be your adjacent. So you know the adjacent, and you are looking for opposite. Now let me show you how you can do that, just as an example. Okay, because we just want to make sure that we can do and solve the real life application. We can do some real life applications with these trigonometric functions. So let's say we take tangent. Tangent 24 degree, because you know theta is 24 right now, is your what is the formula for tangent? What is the ratio? Opposite by adjacent, right? So here the opposite is A, and adjacent is 1200 years. Is this the formula? Make sure you understand why I write this. Tan theta equals to opposite by adjacent. If this is right, you want to find A, so you want to get rid of 1200 in the right side. You multiply both sides by 1200, so you will end up with something like this: 1200 times 1024 degree. Can anyone help me to find 1024 degree using calculator? What is the value of 1024? How much is that? 0. Something like this. Okay. So you know 1045 from the calculator. As I said, it's a constant value. So when you multiply these, how much you get? 534 years, right? Point something, yeah. I'm just trying to show you that how you can find it. So this is in year because the other side was in year, so it's 534 years. So that is the distance you were looking for. Okay. See, a lot of interesting problem can be solved just using the trigonometric functions. I'm missing that problem because there is an interesting problem. A lot of people try to find. Let's say you are trying to. That problem is not here. I'm really missing that problem because I have seen it in so many places. That's why probably people are trying to avoid that because it's so common right now. Let's say there is a river, okay, and you know the width of the river, and you know anytime you are crossing a river, there must be a current flowing, right? Because of the water flowing, so that's like current flowing. Now, even if you are trying to cross the river vertically, let's say, okay, you will not be able to do that because of the other flow along that line. So what will happen is, let's say this is the river, and you are trying to cross the river this way. This is the width of the river, right? But you will be crossing this way. Do you see what I'm saying? Because the current is flowing here. If the current is extremely strong, this will be more decline. Do you see what I'm saying? So a lot of times people try to find something from here. For an example, let's say you know this width. For an example, let's say you know this is 50 feet. Okay, 50 feet is too small. Maybe 150 feet. Okay. Okay. Now let's say you know this is 50 feet, and let's say you know this angle or this angle, whatever. So even if you know this angle, you will be able to find this angle because this is 90 degrees, right? Now, so here is your triangle. I'm saying the right triangle. So you know, let's say you know this angle, which is theta, right? You know theta, so this is going to be your opposite side. This is your adjacent side. This is the hypotenuse. Now, given this, what you can know is, let's say you wanted to reach here, but you will be reaching here. Now, one of the interesting questions can be how far you reach from your destination. So, for an example here. Or another interesting question can be how many feet you basically traveled to cross the river. That is basically this much, the hypotenuse. So all these questions can be answered just from the trigonometric functions. Okay. This was so common example, but people is trying to avoid it because it's so common, I think. So I think we all have tried it. There are some functions called trigonometric inverse function. We'll go back to those points. We'll be going that point towards those sections. But just for now, if you want to use your calculator, you can also do that using the calculator. Inverse function is something that gives you the reverse side. For an example, let's say you know the value of some trigonometric functions. Let's say you know that for some theta, sine theta equals to half. Now, what is the value of theta? You see what I'm saying? In general, the trigonometric functions take theta and give you the ratio. Now, let's say you know the ratio for some theta, but you don't know that theta. What is the angle? You don't know that. So in those cases, we use the inverse function. Okay, we'll discuss about that. I'm just showing you because you see the inverse. And as I said before, the inverse function is not like 1 over sine, not like not as we have seen in the inverse functions, that f inverse is not like 1 over f. It's just written because we have, that's the best way we can represent the inverse function. Oh, this is another interesting example. Let's see. So let me just check whether we understand the problem. A building is 40 feet high. So what you know is, this is the height of the building, you know that. It casts a shadow 36 feet long, which is, this is the shadow, let's say. Now, find the angle of elevation of the sun, because it may not be exactly accurate, but that's why. But so what you are looking for is, you are looking for this angle.
Okay. Now, for this problem, what you are looking for? You are looking for the angle. Okay. For this kind of question, you will need the inverse function. Because look at this. At this point, the angle is not given. In most of our cases in past, in the previous, our angle was given and we tried to find the so what you should do is this. Let's say so first of all, what do you know? So let's say this is your theta. What is given to you? Opposite side and
adjacent side. What will be the best approach, best trigonometric functions for that? Tangent, right? Because tangent is, what is tangent? It's opposite over adjacent. So what is opposite here is 40 feet and the adjacent is 36 feet, which is, if you do some simplification, over 9 maybe, right? After the simplification. Now at this point you have tan theta equals to 10 over 9, but interestingly you are looking for the theta. So what you can do is you can write this. You can write theta equals to tan inverse of 10 over 9. See, people think it in all different ways. Some people think that I'm moving tangent from left to right, so that's why it's inverse. That's not exactly what you are doing, but that's the way some people think. Or some people think you are basically doing tan inverse in both sides. Then this side tangent and tan inverse get cancelled. But this side there is a tan inverse. So now what you can do is in the calculator, using the calculator you can find this. Because the inverse functions take the ratio as an input, give you the angle as the output. But still we are talking about the trigonometric functions. It's the same thing, same way, but you are finding the angles instead of ratios. What is the angle? Everyone has 48 degree. So what is the cos theta here? You are given adjacent and opposite. What is opposite here? A is the opposite side because theta is capital A. And so what is the formula for cos theta? Now remember, you will need the hypotenuse for cos theta, right? How do you find the hypotenuse? Pythagorean theorem, a square plus b square, square root, right? So I think it's the square root of 10, right? Is it a square root of 10? May I erase this? Anyone? Okay. Okay, so C equals to the square root a square p square, right? Using the Pythagorean. So when you when you plug a and b, it's 1 square plus 3 square, which is 1 plus 9 whole square, no, square root, and then a square root of 10. This is going to be your C. Now you know C, A, and B, all of those. So for cos theta, what do you need? Adjacent over hypotenuse, right? So your adjacent is 3, hypotenuse is square root of 10. So the right answer is, oops, is basically A, because A is the same as this. I'm not sure
how they found it. They probably used a different method to do that. That's why they have a peculiar answer, but that's the same thing, because when you try to cancel these, or if you just do the math in the calculator, you will see they have the same answer. Yeah. So you multiply both denominator and numerator by square root 10.
You see the same answer. So A is nothing but equal to this. So the right answer is A. Or if you just plug it in the calculator, you see the same value for A and B. So this is again another lesson that if you are answering the multiple choice question, sometimes the answer may not be in the right shape, but there's also the right answer is the same value. So the right answer is A here, since they have the same. All right, so this is an application problem here. Find the height of the tree if the length of the shadow is 50 feet. You see the length of the feet is already marked there in the picture, and also the sun is at 30-degree angle. So this is your 30-degree angle, this is your length of shadow, and you are looking for the height of the tree. Now, you can easily see the triangle, but remember, if you encounter such question in the test or in the quiz, you will not see this picture most of the cases. So that's another thing, that you have to create the picture. That's important, because you have to create the picture and you have to see the triangle, right triangle. Once you have the right triangle, you are almost done, because you know those hypotenuse, adjacent, opposite side angles. Now, what are given? You are given theta, you are also given what? Adjacent side, right? And you are looking for the opposite side, because the height is the opposite side for us, right? So what is the right formula? Function, tangent, right? Chord also works, because you know chord and tangent are the same, because it's just flipped. So the tangent may be the right formula here. So if you take the tan 30 equals to opposite over adjacent, which is h over 50. So the h will be 50 tan 30. 50 times tan 30, right? So it's 50 times, is tan 30 1 over square root 3? So the answer is going to be 50 by square root 3. If you use your calculator, you can find the answer. But make sure when you answer in the multiple choice, don't always find the fraction, because sometimes the answer may be given in this format. Or they might do something else. Look at this. It can be tweaked and twisted. They can multiply numerator and denominator by 3. Then, square root 3. Then this becomes 3, and it will have 50 square root 3. Right? Then they may divide 50 by 3, which makes like 16 point something. I don't know exactly what they will do, but try all different ways of getting the same answer. But in decimal fraction, the answer will be the same. Doesn't matter what you do, as long as it's right. How much is that? It's 28.87. Is that the answer? Yeah, because I was guessing, because it's square root of 3 is 1.73, so close to 28.87. So all right, so we stop here for this section, which is section 4.3. So we'll stop here.